Hey, it's Chris, hiding out in the forest from my super energetic grandkids who are about to discover me. They say I should push them on the swings every minute of every day. I was working on an episode on wheat sensitivity, and I was really interested in the question of how much does it matter what kind of wheat you eat, and how much does the processing matter? And I discovered a guy, Bob Quinn, who wrote a great book on those questions, Grain by Grain, and he is a PhD plant scientist and an organic farmer, and he's been involved in human nutrition studies. He's a unicorn. And I thought you might want to hear the interview that I had with him before creating that episode. This is one of the ways I fact-check myself and ask questions and get new insights. Bob and I went on and on for 2 hours and had a great time. I didn't think you'd be interested in all that, so I tried to edit it down to less than an hour. So here you go.
Oh, I'm glad you wore your big hat.
Oh, yeah, I couldn't. I'd feel half naked without it, you know.
Oh, you look good in that. And that's your wheat in your hat?
Yeah, that's the Kamut.
Oh, that's really great. I have to apologize. I'm not done with my breakfast yet. I'm having some porridge.
Well, it's early for you. I know it's only 9 o'clock, right?
This is really delicious. It's an exotic ancient grain called Kamut. I heard it's from King Tut's tomb.
Oh, yeah. Well, that's what we heard too, but it turned out not to be so. But it still doesn't make it any less delicious.
Yeah, and it's a great story. Although the story you heard in Turkey might be even better about Noah's Ark, but we'll get to that.
Okay.
But first, I wanted our listeners to hear a little bit about you, starting with your education.
Well, I attended kindergarten in Big Sandy, Montana. I went to elementary and high school in Big Sandy. There was 40 in my graduating class. 160 altogether in the high school. Now there's around 80 or so. So it's really declined. I went on to Montana State University, studied botany, got a degree, MS in that, and then a year later I had an MS in plant pathology. And then I went on to UC Davis and got finished a PhD in plant biochemistry.
It's so amazing because I found your book. I don't know how I found your book. This book should be known by a lot more people than it is. I was just trying to sort out some of my own curiosities about wheat and some of the problems that I've had and my family's had and so on. And everything seemed so vague until I came across your book.
Wow.
And I thought, well, you know, he describes himself as organic farmer and scientist. What kind of scientist is he? A PhD biochemist. And he grows the wheat, and he funds research. This is like extraordinary. I mean, is there anybody else like you?
Oh, I'm sure there are. I'm sure there is.
No, there may be, but I haven't found any.
Well, I got a little discouraged and disillusioned with university. Then I came back to the farm, and I turned my whole farm into my laboratory. So over a course of years, and now that's become my main focus as I rented out the farm 3 years ago now, to my employees, and they're running. So I downsized from 4,000 to 4 acres, and on 4 acres I grow my own food and do my little experiments. So that's what I'm focusing on now.
So talk about one of the disillusioning things that you faced in a peach orchard when you were a grad student.
Well, that was actually the first time I had ever questioned what we call modern, what I call industrial chemical agriculture. And when I was growing up, we got our peaches in wooden boxes. They came double wrapped. We're in Montana, in northern Montana, so we can't grow a single peach in the whole state. And they came from probably California. And we would buy them, open up the wood box with a hammer and opener, some kind, and put the peaches out on the counter. And within 3 or 4 days, they were ripe, fully ripe, and just heavenly delicious. And when I went to California, we lived in Woodland, and there are some peach orchards around there, and we'd go out to get peaches to can because of being poor grad students. We had to buy at the bottom of the food chain and preserve our own food best we could. So we would can lots of food, fruit, and mostly fruit during the season, and then eat that all year. But we went to the peach orchard, and the guy in charge says, "Well, do you plan to can today or tomorrow?" And then he would tell us which pile to go to. And so they were fresh picked right off the tree, and the ones for today were tree ripened nearly, or they'd been sitting there maybe a day or so, and they were ready to can. They were fantastic. But we went on this field trip, to the Central Valley of California with a crop science class, and we went to a peach orchard, and I looked at the peaches on the trees, and they had this beautiful blush that indicates a ripe peach. But when we had one, well, I tasted one. I'm not sure if we were invited or not, but anyway, I couldn't resist. And I had one, and it was awful. It was green and hard as a rock. And when I asked about that, the owner and the professor had kind of been in cahoots to develop a petroleum spray that could be sprayed on these peaches that would turn the skins a beautiful orangish, yellowish blush that tells you the peach is ripe and delicious. And that's what they had figured out. But they weren't ripe and delicious. They were green as grass inside and hard as a rock. And therefore, rather than pick them and wrap them twice, hand by hand, and put them into wooden boxes, they could dump them into bins that probably hold a ton or so of peaches and ship them across the country without any bruising. And that was what their progress had been. And I thought, wow, if this is progress, I'm not very excited about it. And I think that we're going in the wrong direction. That's what I thought. And that really, it wasn't continuous. My thinking then, it was kind of, a thought here, not there. It evolved. But that was the first time, I can tell you that's the first time I started questioning the modern agricultural, industrial, chemical complex and what they did to our food.
So you're in California. You have a PhD now in biochemistry. You would think you'd be pretty marketable. You decide to go back and join your dad on a farm in way up north in Montana, right? It's dryland farming, and you can't get the kind of you can't get as number of harvests per year. In fact, you have to go every other year or something like that. Right. Seems like a hard way to make a living up in Big Sandy, and a lot of the neighbors were moving out, and you were moving in, and yet you somehow chose to do that.
Well, it was for me. It was going home, so it wasn't so strange and hard. I was used to it all. When I came to California, I had orange trees and a grapefruit tree in my backyard. I thought that was, it had a garden I could grow 12 months of the year. I thought that was just heavenly. But it's interesting. After about 2 or 3 years, I thought, wow, I need a break. I kind of like the seasonal idea where you have a summer and work hard, and then a winter and relax a little bit. And I missed that because I was going, of course, I was in graduate school most of that time, and I was going hard anyway. But there was no, what would you say, a break from my garden where you kind of start over. You did start over in the spring, really, but you were just finishing up winter also in the spring. So it's kind of a two-sided sword, and I didn't think about that before. So I was more comfortable with what I was used to. Even though I was really restricted in what we could grow and enjoy, it was what I was raised with. And my grandfather started this farm in 1920, and my grandparents are still alive and there, so it was a great opportunity for me to come back. And even though people thought I was kind of crazy for turning my back on 10 years of college education, it wasn't a waste. I brought it home with me, and I used ideas and principles from that throughout the rest of my life.
And how long ago was that when you got your PhD? Was that like 40 years or something?
Well, I got it in 76. So it's 45 years.
That's a while ago, yeah. So you're a little older than I am, but so I have a sweatshirt that says made in 1953, all original parts.
Oh. Well, then, yeah, we're close. Mine would say 47.
Yeah, we're close.
Yeah.
Yeah. So you wrote this book, Grain by Grain. Mm. I found it to be fascinating. I listened to it on an audiobook when I was driving, and I just could not stop. I'm driving around in circles and everything else, just thinking, wow, I found somebody who really understands wheat. And before I get into the way you farm, and especially the health benefits of heritage wheats, which I think is what most of our listeners are really going to want to know about, I have to say, I watched a lot of documentaries on wheat, and they're so vague about what the word means. They never really define what is wheat. And I've never been all that clear either, but they sure make sort of provocative covers, like it's poison. It's become sort of the thing. It's poison. 3 good reasons to delete wheat.
Yeah.
The war on wheat.
Yeah.
I haven't watched that one yet, so I don't know much about it. But in watching the other two, it's like, can you describe what you mean by wheat? And to me, it seems pretty fascinating because everything from einkorn, I have einkorn berries over there, to modern wheats. To me, it seems like using the word dogs to describe, dogs or something like that. They seem quite different. So, like, can you describe a little bit of the history of wheat and the differences between, like, einkorn and Kamut and Emmer and all of those 14 chromosomes, 28 chromosomes, 42 chromosomes.
Okay.
And all that.
Well, you just stopped me if we're getting too far down the rabbit hole here or in the weeds. But wheat is a genus of triticum, and so it's a well-defined classification of plants. And I won't go through all the details. Most people, I mean, if you see a head of wheat, that's typical of the family. It's and there you got some right behind you. I've got
Blackbeard. Yeah, you've got Kamut up there. It's called Blackbeard wheat.
Yes,
it's an ornamental wheat.
No, and it doesn't matter if it's blackbirds or yellow or golden beards. It's all can be in the wheat family. Just like the dogs you mentioned, there's all types from little to big, and and all kinds of personalities and everything. The wheat, however, is a little bit different family in that it has 3 main divisions. One has division is called, well, it only consists of a set of chromosomes from each parent, like we have. So it's with only one set of 2 pairs. So that's normal for most of the animal kingdom. And most of the plant kingdom, wheat's a little bit unusual that it has other formations than that. So it's called a diploid, a diploid. And then you have, and an example of that is einkorn. Einkorn is about the only grain in that classification that is commercially known or available or important. The next group is...
Can I stop you on einkorn for a minute? So that's the oldest of the wheats, right? And it could go back...
it's the simplest. Why don't we say it that way?
Simplest,
It's hard to know. Did they all evolve together? Well, I don't know. It probably started with that, with the 2, and then it evolved adding more. So you might say that you might get away with that, but no one was around to, take talent. But you can say it's the simplest and therefore probably the oldest.
And it grew wild. And archaeologists have said, at least in one paper that I read, wow, we've now got evidence of it being 75,000 years, tools to work the wheat from 75,000 years ago. So people must have been harvesting it wild or something. And then it somehow combined with goat grass.
And formed what they call the tetraploid. And that was passed down. And so now you have 2 sets of chromosomes. So the unusual thing about this is that the goat grass and the einkorn type didn't just form a hybrid with one new set of chromosomes containing parts of each. They formed wasn't a hybrid, it would be a different classification of plants. The tetraploid with 1 set from each, or 2 sets from each parent. One was from the goat grass, one was from einkorn. That's quite unusual. And so I don't know how that happened. But anyway, that's what you ended up with, and that's called a tetraploid. 2 sets of chromosomes from each parent. Now you have 4. So hence the word tetraploid. And examples of that is durum is the most common example, which is used for mostly with pasta. Emmer is in that group. And the Kamut coruscant that we grow and market and promoters in that group also. It's a very, very close relative to durum. The next group is hexaploid, and it ended up with 3 sets of chromosomes from each parent. So there's 6 hexaploid. And the most common that group is our modern bread wheat. Spelt is also in that group. Those are the most common ones that people would know. So that's how it's divided. And if you look at the complexity, it gets more complex with each step up in the number of chromosomes.
Does the gluten change with each step up?
Yes. So
In what way?
mostly qualitatively, you know that you can't really take durum wheat, for example, and make a fluffy white loaf of bread. The protein, the gluten in it isn't designed for that. Nor can you take bread wheat and make a beautiful golden pasta that sticks together easily. I mean, it can be done, but it's not routine, and it's not the best way to use it. So you can see for yourself when you're cooking that the protein is different. And if people start to have, we'll probably talk more about this later, but people who have sensitivities, generally they have more sensitivities with the more complex wheats.
With the bread wheats.
Yes.
So I read a brief history of wheat in the United States, and I have old cookbooks and things, and I've tried to piece it together. Fact check me. Briefly, I just thought that what I read was cornbread was the most popular in the Americas into the early 1800s. And wheat was mainly used for porridge and flatbread. But it wasn't until later on when the Mennonites brought hard turkey red wheat from the Ukraine that we got really good bread wheats that would rise. And then that became the killer feature of wheat. And wheat just took over, and through the early 1900s and so on, these big white, soft, air-laden breads kind of took over. Is that...
well, that might be a little bit of oversimplification.
Romanticized.
But the corn was native to America. Mm-hmm. And the Indians, the old Pilgrim story and Thanksgiving and all that stuff,
yeah.
They were, the colonists were introduced to corn. I don't know how much they became dependent on it, but certainly to a certain extent. I don't know how much, what percent it was of their diet compared to wheat, but you see old pictures from 1700s in early 1800s of corn cribs, so they certainly had it. Mm-hmm. And it was probably more than just for their animals. The colonists also brought with them wheat from Europe, where they came from. And the early mm-hmm. ones were mostly from England, so they brought wheats from England. Those wheats were soft wheats. They weren't hard wheats. And so you're right about that. They didn't make the kind of fluffy bread that would rise up very much the way that we're used to seeing it now. But it would make make some type of a bread or a flat bread or whatever they were used to, biscuits or muffins or, biscuits. You hear them talking about that a lot. Certainly that was common in the Civil War. I mean, I have letters from my great-grandfather talking about how much bread rations they had and that sort of stuff. So it was, I don't know that it was cornbread. I'm not I'd be surprised about that. Although I'm sure cornbread existed and was around. But when the Mennonites showed up in Kansas first in about 1880 sometime, when the homesteading opened up there, you're right, that's when the hard red wheats were introduced. So turkey red was the most common. And when they got to Montana, the first records in Montana from 1911 show that turkey red was the predominant variety grown, and that was true clear up to the middle of World War II. So they were predominant for over 30 years. And it was mostly through the whole prairies that it was that way. And once railroads became, were built everywhere and rail traffic became cheap, you're right, the wheat was shipped out, and the wheat production in the East and in New England and the Mid-Atlantic states almost disappeared. But it had stone mills, they had wheat fields. It was a big thing in the 17 and early 1800s for sure.
And then along after the war came Norman Borlaug. Does he get talked about much? And what kind of I got a book on Norman written by one of his colleagues, and I was reading it in bed. I never should have done that, and I just couldn't put it down, and I read it all night long, and I missed a whole night's sleep.
Oh, wow.
Because of that. But it seemed like do you want to describe what he did and how it changed wheat?
Well, he had a very a big goal of ending world hunger with better wheats and more high producing wheat. And so he, particularly looking at India, I remember when I was little, India was always starving. It was almost equal to China for, cleaning up your plate because of the starving children in China. As my mother always told me. But
mine too.
Yes, it was. I think everybody did. We need more of that, though. Really, we should be cleaning up our place, taking less the first place, but cleaning up what we do take. Anyway, he ended up in finding some dwarf genes in some types of wheat, and he introduced those into bread wheat, typical and high quality bread wheat, and it did increase the yield significantly. So what you were doing was taking the wheat that would the wild wheats, as you mentioned earlier, the heirloom wheats that were normally with proper water. Even in our place in Montana, we could see wheats that were 6 feet tall, sometimes were 7. And you only eat what's in the head, at the very top. And so the idea was, well, let's just make it shorter and put more energy into making seed and making more yield. And he was very successful with that and introduced that all over the world, particularly in the wheat growing areas of the world. We ended up with semi-dwarf varieties that are very common out of Montana, and they are higher yields in some years, not always, but in drought years they are really, really short and hard to harvest. But we usually hope it's not going to be a drought year. So they do have a little disadvantage for the farmers in the semi-arid Great Plains, of course, but those that are irrigating or don't care anything about that and have plenty of water, they can always grow up to a good height that you can harvest. So that was the main, that was a big contribution that he made. And that was, when was that? In the 60s sometime? I'm not sure when that was.
Yeah, 50s, 60s, 70s.
Yeah.
I think it's astonishing. He got a Nobel Peace Prize.
Yeah.
He got the Congressional Gold Medal.
Yeah.
He got the Presidential Medal of Freedom. There's a statue of him in the rotunda of the Capitol.
Really? Oh, I didn't know that.
Yeah.
I haven't seen that.
And he got the highest civilian award. He got 50 honorary PhDs. He got the highest civilian awards you can get in Pakistan and India and Mexico.
Yeah.
It just,
right,
but some of the legacy has been he also brought in big scale commercial farming with lots of nitrogen. Some of the wheats that he bred were able to tolerate large doses of nitrogen, and part of the dwarf idea was that he made the berries so big the stalks were falling over, and some of those things.
Well, if you're going to have more grain, you're going to have more nitrogen to make it. So it was really a combination between just having a potential for more yield and actually realizing it through greater fertilization. And that really played into the agricultural chemical industrial complex. Yeah, and that's and those two really went together, and it really forced farmers, if they wanted to maximize their yields, they had to maximize their nitrogen, and that meant that in most cases they had to supplement what was there with the commercially manufactured nitrogen of some sort. Urea or ammonia or something.
A lot of it.
Yes, and a lot of it. If you're gonna have high yields, if you got enough water to really have big yields, then you have to have a lot of nitrogen to make sure that the protein is good enough for bread making, because you have to have a certain amount of protein in each one of those kernels to provide the gluten and the most of the gluten to make the bread rise up the way that you're expecting it to do, that the bread bakers want it to do.
I saw a list that he had made of the 9 things he was trying to achieve with his wheat.
Oh.
There's a lot of things there. Yield was one of them. Rust resistance was another. Kind of pests. I think that he was a plant pathologist, right? And so his initial mission was to solve the rust problem that was plaguing the world. But he went on down the list to, he had to make it pleasing for the millers.
Yes.
And also the bakers. Yes. It had to be good bread that rose high. People, can you describe that? In somewhere I heard you say that with the advent of steel mills, the bran changed, and so it became brittle and scratchy and didn't make good pasta?
Well, okay, that was my first experience going back to whole wheat pasta as a comparison to what the Kamut was tasting like or feeling like. It's the texture in the this is now the late 80s. So what's happened as you go back to the purpose of plant breeding is to increase yields. I mean, that's the main function. And it's not just for farmers. The yields are also looked to increase for the millers and the bakers. The farmers, you've already mentioned the things that they made the plants shorter. They made them more disease resistant. They made them more pest resistant. And I'm not sure how much that really affects the sensitivity problem. It would be interesting to be able to tease that out. But if you go to the millers, then they wanted more yield too. So how do you get more yield when all you do is make white flour? Well, you get more yield in a mill making white flour by making the bran harder and harder so it flakes off with less and less endosperm, which is the white portion of the kernel, which makes the white flour. So if you can increase the what they call the extraction, then your yield goes up and you're making more money because you're not throwing so much away to the pigs for feed. And that's what they do with the bran. I mean, the pigs in this country are eating better than we are. So, and that's why. And then you go to the third group, which is the bakers. They wanted more yield too. And the way they got more yield was by plant breeders making gluten stronger and able to hold more air, because the bread rises because the air that is trapped inside the cells of gluten as the yeast digests the sugars first. Now they have pasteurizing yeast, so it really only has time to digest sugar, and it releases alcohol and carbon dioxide. And the carbon dioxide is the gas which is forming inside the bread. If the gluten is weak, those little bubbles gas bubbles that are forming then will explode. They will break, and then the dough will not continue to rise a little bit. It'll go down every time they break. But if they don't break and they just get bigger and bigger, then the loaf goes up and up. So imagine this: if you were a baker and you could sell air for the price of bread, if you're selling it by the loaf, for example, and that was very attractive. And so if they could use less wheat to make more bread, the bakers were very interested in that. And changing the gluten, which is something we eat, I'm not sure about changing genes and the height of the plant. I'm not sure how much of that goes into actually the kernel and changes the way the nutrition of the grain. I don't know about that. I also don't know about the nutritional change from making the bran harder if you're not using the bran anyway. It certainly makes the texture more coarse and sharp if you eat it, if you don't just pulverize it. But the gluten change is something we eat, and I think that really is the most suspect of causing, when people have trouble eating wheat, as being the cause of that. You know, wheat was used as the basic diet for thousands of years and just fantastically successful and long-term civilizations of like Rome and Egypt and the Babylonians and Phoenicians, all those folks, diet was based on wheat. So how can it all of a sudden in the last 30 or 40 years become like those books you showed me earlier, poison and all this stuff? They're throwing the baby out with the bathwater. So they're just painting such a broad brush, and they say, oh, wheat is bad. That's not true. There is some wheat that is bad because of the way it's been changed. But it doesn't mean that we started out that way, nor that all wheat is bad.
So let's get into the health aspects. In my view, there's three dimensions of you. There's your educational background, which helped you understand how to grow organic wheat, but you've also funded a lot of research. You, in your interviews, you threw out this number of, you think people's sensitivity to wheat is somewhere around 12 to 20% now?
That's what the literature says.
Oh, that's what the literature says? I wondered whether you got that number.
Yeah, in America, the percent of people that have some kind of trouble eating wheat is between 12 and 20%, wow, depending on whose study you're looking at. It's significant.
I've also heard you say there are four things that are contributing to it. You kind of glanced over one, the yeast.
Yeah.
Can you go through those four things?
Well, I tell people that have trouble, there are four things you can do to probably give yourself an 85 to 95% chance, a real high chance that you will no longer have trouble with wheat. So the first one is to eat only ancient heirloom varieties and make sure that that's what they are, and it's just not some fancy marketing thing. That it really is truly what you're expecting. The second is to eat only organic, so you don't have the possibility of having eating chemical residues. Glyphosate, for example, which is the main component of Roundup, imitates some of the same symptoms that people feel and blame on wheat sensitivity. It's actually a pesticide sensitivity. So that's the second thing. The third thing is eat whole grain. You're getting the whole, not only getting the whole nutrition, but you're also putting your body into a better situation to fight against maladies and other problems, and wheat sensitivity contributes to those. And the fourth thing I'd say to people is to eat sourdough. If you're going to eat bread, eat sourdough, because sourdough is a fermentation. It's made from bread that's been fermented for at least overnight, sometimes 24 hours, sometimes longer than that, particularly if they're refrigerating it. And it's being fermented by a combination of yeast and bacteria. And within 48 hours, about 90% of your gluten is destroyed. So even in 24 hours, or even 12 hours, you're getting a significant reduction in gluten the way it exists in yeasted bread. And yeasted bread, as I mentioned earlier, is made with fast-rising yeast. It doesn't, and the bakers don't even give it time to start to digest the gluten or the starch in the bread, because they add sugar to the bread, and the yeast is immediately attacking the sugar because it's so simple to break down. And most of that, the food for the yeast before it goes in the oven, is sugar. And it's not, they're not really having time to get to the gluten yet and break that down, or help start to break it down. But if you use something that's digested where a third or half or 2/3 of the gluten is gone in its original form and broken down in the simpler components, then your body just has to finish the job. It's not near the problem. Even with modern wheats, it helps you. Any one of those four will help you, but putting all four together will give you the maximum possibility for being able to enjoy wheat again.
I'd like to ask a few questions about some of those things. One is organic. I had understood, I must be grossly misled, but I had understood that the government owns the word organic. You've acknowledged that. And that it doesn't mean farmers don't spray. And I'd heard on podcasts over and over, farmers spray, they all spray. There's 250 approved sprays. It's just that they stick to the approved sprays. But you don't spray.
No, we don't spray. But
so how do you do that?
Well, you farm in the northern Great Plains where it doesn't rain, and without rain and being very dry, we very rarely have fungus problems. We have such harsh winters. It's not 40 below anymore the way it used to be, but it's still over 30 below, 30, 35 below every season. That takes down the insect overwintering.
And you left California for that.
Well, it has its own beauty, Chris. You'll have to come and visit sometime. I'll show you.
I love Montana.
I'll show you what we love. I mean, we don't have everything, of course. John Steinbeck said if Montana had a seacoast, it would be complete. And California has lots of that.
Yeah.
But every coin has two sides, and we just enjoy the side. We focus on the side we enjoy. How's that?
Oh, yeah, that's great. So let's talk about glyphosate for a minute. I was looking at some of my understanding is some plants are beginning to become even glyphosate resistant now.
Yes.
And
weeds.
So wheat is?
Weeds.
Oh, weeds, yeah. So I went and looked at some of the chemical company advertisements, and it's like, here's from BASF in Canada. Oh my gosh. So what is total burn down of the fields, and when do people use it? They seem to advertise that at the trade shows a lot.
Yeah.
I don't know if you could see that,
No, it's
a
dragon.
Yeah, dragon.
No, that's pretty. Yeah.
Broadleaf weeds have met their match.
Yeah, of course. Yeah.
And I mean, they're very aggressive ads.
Yeah. Why? They're making billions of dollars.
Yeah, billions of dollars. Think fast and hot.
Yeah, of course.
Just destroy everything. So, and in the advertisement, they're saying glyphosate with some brand name herbicide. So it's not just glyphosate anymore.
No, that's to take care of the resistant problem that was popping up with using glyphosate so much and so often that some weeds adapted to it. They had mutants that formed that was successful to resist glyphosate, and so that's what happened. So then they have to add another chemical, and so we have even more poisons being spread in the environment.
So we're in an arms race.
Yeah.
But glyphosate is an antibiotic too, right?
It is, and that's how it works. It works by disrupting a particular metabolic pathway that's found in all plants, most all plants except for those resistant, which didn't used to be hardly any in the beginning. It is found in bacteria, not all, but most bacteria. But it is not found, and this is the big thing that they started with in the beginning, it's not found in the human body, or most animals don't have this pathway. It makes an essential amino acid that we must eat in order to have our full nutrition. And so we can't make that amino acid, so we don't have that pathway. So if we get a little on our skin or ingest it, it doesn't kill us like it does a plant. But the trouble is that they don't tell you about, and never, and who knows how much, they did a lot of research, they knew there was trouble with this, but what they don't tell you about is you have more bacterial cells in your body than you have human cells in your body. And so if you start to disrupt those, you're going to have trouble because your microbiome, the bacteria in your body, is really what digests your food. It makes all these secondary metabolites that really keep your body well. And if you start disrupting that, then you end up with all these weird and unusual diseases. And you also add to inflammation, which adds to all kinds of other troubles of chronic disease. So that's one major thing. If you get exposed enough, of course, then you're going to get cancer and those sorts of things too. And that's what the lawsuits have been about.
I did an episode on the microbiome a few months back, and there were two charts that were just stunning. They were both published by a professor in France in 2000, and they showed the dramatic decrease as the chart goes to the right, the dramatic plunging of infectious diseases as a result of antibiotics. One of the greatest medical advances in human history, antibiotics. And when you have a serious infection or something, I don't think there's any doctor that questions using antibiotics. But then on a chart right beside it, there was the dramatic increase of autoimmune diseases, things like autism, Parkinson's, irritable bowel syndrome, and so on.
All kinds of chronic disease too.
Yeah, terrible chronic diseases. And they, Crohn's disease was a big one, that's been, so for 20 years, that paper stunned the scientific community, and for 20 years they've been trying to figure out what's going on. And now there's this whole...
20 years ago? This paper is?
20 years ago, yeah.
Oh, I'd love to see an update of those charts. Wow.
Yeah, I think it's getting worse, especially with autism.
No, it's almost geometrically worse.
Yeah, geometrically worse. I mean, I think I've heard you say with autism, the number that I quoted is it used to be 1 in 10,000, young men would get autism. Now it's 1 in 50 or something like that.
Yes, it's 1 in 50. So our grade school has 50 kids, and one has autism. We're right on the dot. But the rate of increase in that I don't know how many years, like 2040 or 2050 or something. It's not so far away if you're young. The numbers are talking about are 1 in 3. It's just astounding. This is a train wreck that we can't survive. I mean, as the way we're working now. And the same with chronic disease. The CDC says right now, 60% of Americans have at least one chronic disease. 40% have 2 or more. And it doesn't matter, everybody would say, oh, well, we're going to have the best health care in the world. Well, it doesn't matter what kind of health care system you have. If a majority of the people are sick, the country's going to go bust. No one can afford it, for one thing. And they don't cure the problem. They give you pills so you live longer, or your symptoms are a little less burdensome. But by not focusing on the cure, The root cause, you can't cure the problem if you don't focus on the root cause, right? You only put Band-Aids on it with pills and drugs, and that doesn't cure anything. So anyway, I didn't mean to get off on that tangent, but that's a big one for me. I'm really focusing on that now.
Yeah, and so in the last 20 years, all these microbiologists have come out of the woodwork and gained prominence by establishing the American Gut Project, where we're all donating our poop samples to see what kind of, and it turns out there's some really big trends in there. Like with autistic kids, the lack of Prevotella, the bacterial species Prevotella, is common among almost all of them. And they manifest, and same with Parkinson's, and they manifest the same way. They have constipation and some of those things. And so now the thought is, wow, this may have a lot to do with the microbiome. It's not.
Sure, that's right. That's right. You're absolutely right.
So let's talk about the microbiome of the soils. You say healthy soils.
Back to that thought one more time. So how the government's going to fix that? They're going to say, well, we need to inject this missing bacteria back in your system somehow.
Prevotella, yeah.
Rather than say, well, what killed it in the first place? What happened? That's the question we should be asking. Not how to fix it, but how it got broke in the first place, so we can stop the water. I remember an old Chinese proverb, and they said that it's useless to if you have a broken pipe to just be cleaning up the drippings all the time. You need to fix the pipe, and that's what we need to do. So anyway, I'm sorry I had to say that, but go back to your question in the soil. That's fine.
Well, so you've said healthy soils create healthy food.
Yes, yeah.
It seems to me the worst thing you could do for the soils is to expose it to the sun and let it blow away and kill it with glyphosate and everything else, and then start from there to grow your wheat. I mean, what kind of microbiome does the soil have then? Where do the worms and everything else go? The bacteria, they're probably burned to the ground, right?
Well, Chris, the trouble is that most people don't look at their soil that way. They look at their soil as dirt. Healthy soil, making healthy food is not original with me. Rodale, J. Rodale has coined that, and the Rodale Institute's been pushing that for years and years. But I believe it, and it's true. But if you're focusing on the way I was focused when I grew up, went through high school, ag classes, all kinds of college plant classes, even into graduate school, you focus on feeding the plant. And so you fed the plant chemicals that you thought that it needed to grow properly, to produce a good crop, and you didn't give a darn about what was going on in the soil because you were feeding the plant. You were taking care of the plant. And now what you're describing is a complete change, a diametrically shift in thinking to focusing on the soil. And now those that do think this way say we should feed the soil. And if we feed the soil and have a healthy soil, then the soil will feed the plant in the right way, in the best way, I should say. And that's the difference. And it's as simple as that. That's the difference between regenerative organic and industrial chemical agriculture. It's as simple as that. Our focus is on feeding the soil and regenerative organic. The focus on industrial chemical is feeding the plant and focusing on and protecting the plant in any way we can.
You have funded research across a whole host of areas. A study on sensitivity to Kamut, course on wheat versus common wheat, rich source of biodiversity, studies on antioxidant, anti-inflammatory properties, understanding the link between diet, gut, effect of diet on symptoms of irritable bowel syndrome, nutrition for cardiovascular health, non-celiac wheat sensitivity, diet and management of diabetes complications. So I read those two diabetes papers that you, they were small samples, 24 people, I think, median age around 64. They had diabetes. But going back and forth between Kamut and regular wheat, whatever the regular wheat was, it was dramatic. I mean, they had 4% reduction in cholesterol, 20% reduction in blood insulin levels, 10% reduction in blood sugar levels, and so on. But what can you talk about that a little bit? What explains all that?
Well, Chris, we don't understand the mode of action on this. And even though those studies were small, I mean, because they're very expensive, and we can afford You know, we're not the government. We couldn't afford millions of dollars in a single experiment and studying hundreds of people. So we studied 24, but they were crossover experiments, double-blind crossover experiments. No one knew what they were eating. They ate one diet that we gave them and another diet we gave them. One was based on, we gave them modern wheat and ancient wheat in the form of pasta, bread, crackers, and sometimes flour. And they could make whatever they wanted. And we told them, do not eat any wheat products either outside your home or in your home. And if you're going to a restaurant, take your stuff with you. No exceptions. And then they ate that diet for 6 or 8 weeks. I'm not sure for the diabetes study, but those are the terms we normally use. And then they would have a 6 or 8 week washout where they could eat whatever they wanted. And then they crossed over and each group ate the other group's diet. So it had an internal control, which made it even stronger. So what we saw, and the reason that a lot of these drug companies have hundreds and sometimes thousands of people, because they're looking for such teeny tiny small differences. Some people have a positive, some people have a negative. In all of our studies, even though they're small, nobody had a positive or a negative. They were all either degrees of positive or degrees of negative, and some were just no effect. But nobody crossed over from positive to negative, you know, in a single group. I mean, so they were very, very consistent, which made them much stronger than their numbers would justify. But still, we just call them pilot studies. They were just introductory studies. The thing that the take-home lesson for me in all these is that, another thing you didn't mention, but all the studies also looked at the effect on inflammation. In all these studies, there was a significant drop in inflammation from the modern wheat to the ancient wheat. And they were up to 35 to 45% differences. It was the biggest single difference in any of the studies. And you can't get a difference like that even with drugs. And that's what's amazing. Even those, the drop in cholesterol, on our heart study, everybody was on statins because they'd all had a heart attack. They're all drugged up all the time. The professor said, well, we won't see anything in this study because they're all on drugs. The fact is they did see a difference, and they were significant. So that the mode of action for food is much different than what, you know, a single point, or sometimes more than one, but a limited mode of action for drugs. And it points out to me, the take-home lesson to me was going back to the whole idea that Hippocrates taught 2,300 years ago, that food should be your medicine and medicine should be your food. And I think the sooner we get back onto that and just turn our back on big pharma and the billions they're making. I mean, they're in cahoots with big chemical. And now we have people like Bayer that own both. And so, you know, they don't care if their pesticides make you sick, because they're going to sell you pills on this side to make you feel better. And so they're collecting money coming and going. And that's why there's no incentive for that sort of thing. And they've got such influence in the government. There's going to be no government lockdown on that kind of thing at all. It doesn't matter which party's in power or nothing, because they have their lobbyists there and they make sure that nothing serious happens to their nest egg. But if individuals would start just eating better and eating more healthy and looking at a more healthy lifestyle, you know, don't sit on the couch all day and night, that would do way more than medicine could do. I mean, but the kind of things you're talking now, in the time of our grandfathers and great-grandfathers, when the antibiotics came in, that was a wonder drug. But they were eating very healthy in those days, most of them. And now that the infectious diseases are not the item of most concern anymore, now the bad nutrition that most people are experiencing is causing this great increase in much more serious situation we had with infectious disease.
Bob, have you heard of this book, Fast Carbs, Slow Carbs?
No, I haven't. I'm sorry to tell you.
It's by David Kessler. So David Kessler, I was going to have him on the show until President Biden stepped in, believe it or not, and asked him to run the coronavirus task force when the administration was making.
Oh, okay.
So he was the FDA commissioner for 8 years under George H.W. Bush and Clinton, and he's the FDA commissioner who went after the tobacco companies and had such success.
Oh, good for him.
And then he went on to be dean of the Yale's medical school for 8 years. And this book he wrote on fast carbs, slow carbs. You had 4 things. Maybe you'll add a 5th after looking at this book. He just talked about the way food is processed food is prepared, including whole wheat bread, whole grain, anything. What the food companies do and the tricks they get up to. He's a pretty good sleuth. And one of the things that was very unfortunate is he said, when we do studies of inflammation and adverse effects, we're not seeing a difference between commercialized whole grain bread and white bread, Wonder Bread versus whole grain bread. And I thought, how is that even possible? What goes behind it and so on. But as he described it, he said the way whole grains are processed now is the millers separate the bran from the germ from the white part, and then they put them back together, not necessarily from the same batch of wheat.
Or the same, or in the same percentage makeup either.
Yeah, and they process each one separately,
Right.
And so, and as a result of that, and so I started digging into some of the definitions of what whole grain means, and I went to the European definition that they. Yeah, and I read the whole 11-page thing. They spent a couple of years with 50 scientists on monthly meetings just to define what whole grain meant.
Yeah.
One of the things they said is, well, you can't lose more than a certain percentage of the bran. You have to lose a little bit in the polishing process or whatever. All three components have to be there, but they can be reconstituted and from different batches of bread. And it has to be, I'd love to be a fly on the wall when this was in there. I swear I read this, and it's right in the document, that it just has to be 51% whole grain, has to meet that definition. It doesn't have to be 100%.
Yeah.
Now, every country is different. I don't know what the U.S.'s is. I couldn't find it.
Well, you have to dig, but I would be surprised if it's much different than that. But it doesn't have to be in the same proportion that existed in the kernel. It can be, a little dab, and it's whole wheat, and that's part of the problem with marketing and those kind of loose definitions. And that would be a good one to find. I don't know where we'd find that one. I know that it exists. Yeah,
that would be very interesting. I'd love to stay in touch and talk about that. So in doing that episode on David Kessler's book, Fast Carbs, Slow Carbs, I went to the grocery store and started looking at the wheats pretty carefully. And I couldn't understand all the ingredients. I had to look a lot of them up. And I wondered if I can't understand them. I'm an earth scientist by background, but this is obviously a passion of mine. And if I can't understand it, I wonder how many consumers can. But let's test a PhD biochemist. And I'll read these ingredients.
It's been 45 years since I spoke that language.
A PhD biochemist who helped popularize one of the best types of wheat, has been growing it for 40 years, and has funded 31 different research reports on it. Let's just see how you do on this ingredient list.
Okay. Are you keeping tally?
Whole wheat. So this is a big brand. Yeah. This is Oro wheat.
No, I know. I've played that game before. I use that in some of my talks and get Oro wheat. Yeah, it's mainline. So it's mainline industrial bread. That's for sure.
But the main claim here is that it's double the fiber.
Okay. So double than what? What does that mean?
It's double.
Double than what?
Well, their wheat must be better than your wheat because this wheat has double the fiber.
Single, right. We use all the fiber that it comes with, so I guess that's only a single dose.
This has 36 grams of whole grains per 2 slices. I don't know what that means.
Well,
and the package that I got a couple of months ago said no nonsense ingredients. So don't be calling any of this nonsense. I noticed they took that off the ingredients list now. Okay. whole wheat flour, we know something about that. Water, wheat gluten.
Yeah.
So they're adding wheat gluten.
Yep. And
sugar.
Yeah.
Modified wheat starch.
The wheat gluten is probably coming from Europe because they have excess to send to us after they make starch out of it. So. And it's added to a lot of bread to help it to rise even more.
I see. Modified wheat starch. What does that mean?
I don't know how they're modifying it. I don't know.
I'm going to have to dock you 1 point on that.
Yeah,
Oat fiber. Okay, soybean oil.
Okay, now the fiber again. That's going to go into their claim of double the fiber. Then.
Yeah, double the fiber. That's fair. They added some oat fiber, oat bran, whatever. Polydextrose.
That is an artificial. Oh man. Dextrose is a sugar. So it's a type of sugar compound, and that's all I can tell you.
I looked it up.
Hard credit for that.
I looked it up, and the definition I saw was it's a synthetic compound. It doesn't exist in nature.
Yeah.
And it's a mild sweetener.
Yeah.
But the government allows it to be classified as a fiber because it has a mild.
Okay,
It's mildly fermentable.
Okay, that's probably polydextrose. That's probably right. So I don't get any credit for that. It's more than it's probably doing that more for the fiber than they are the sweetness. That's probably what they're.
So they can make their claim of double the fiber.
I'm guessing. I'm just guessing that.
That brings me to the next one: cellulose fiber.
Cellulose is from wood. So
they're adding wood pulp to it.
Yeah. Yeah, but that doesn't market.
Why not?
Well, right? That doesn't market quite as well as cellulose fiber, but it's also, that's what they make paper out of.
I'm surprised you got that one. I thought I would be able to get you on two ingredients, and I was thinking I could get you on that one too, but you got it. I had to look it up. They're adding wood pulp to ice cream and everything else? I don't know if it's...
Well, it's fiber. I mean, everybody wants more fiber instead of eating the plants whole.
Yeah.
Novel idea. Then we add something like...
wood chips.
Probably a lot cheaper. There's a lot of some wood chips around. So.
Yeah, next time I take down one of my trees, I'll know to grind it up and throw it to food.
For your bread loaf.
Anyway, thank you so much for this. It's been absolutely fascinating.
Wow.
I've thoroughly enjoyed it.
Me too. Me too.
And thank you for that book.
Oh, yeah. You're welcome. I hope you can come see us sometime, and I hope I can come down.
I want to.
And visit with you and hear some more stories. And
my wife and I did our honeymoon in Montana.
No kidding. Where'd you go?
Thank you so much for watching. If you give it a like, that'll help me get guests like this in the future. And I love to read your comments and suggestions. If you have a question for Bob, he and I are in touch by email, and maybe I can get an answer out of him. Thanks again.